Okay, so because I've given you a lot of definitions and kind of walked you through, I'm going to run through this one a lot faster. Same set of data. The only difference is this time I want four bins, or that means I want four classes. So the very first thing I need to do is figure out what the class width is. The class width is still biggest number minus smallest number divided by how many bins I want. So 10 minus 1 is 9. 9 divided by 4 comes out to be 2.25. What did I tell you? You always round up. So we have 3 is the class width. Okay, remember what that means? Means that when I make my little bins, and it doesn't hurt to picture those on a number line and know those are like the bottom of your bars. But remember, before we get there, we're going to squish them together, okay? And we'll figure all that out in a minute. But we always start with the smallest number. And then what do we do with the class width? We figure out the next starting number. And we use the class width to figure that out. So 1 plus 3, the next bit is going to start at 4. 4 plus 3, the next bin is going to start at 7. And then 7 plus 3, the next bin is going to start at 10. Okay? And then if this one starts at 4, then this one's going to end at 3. This one's going to end at 6. This one starts at 10, so this one's going to end at 9. And it looks like each one went 1, 2, 3, 4, 5, 6, one number in the middle, 7, 8, 9. So this will start at 10, 11, it'll end at 12. Okay? Now that's creating these little bins like it's, now something that we can take these right here, throw them in, okay? That's, what you can imagine. But most of the time, you're going to be working with a table value, and they're going to want you to write down your class limits, okay? You've calculated your class width. You know your starts at 1. So it's 1, and then you add your class width to get your next starter, add your class width to get your next starter, add your class width to get your next starter, and then you kind of work backwards to get your ending points. So if this one starts at 4, that one stopped at 3. This one stopped at 6, this one stopped at 9, and this is plus 3, this one's plus 3, so this one would be plus 3. Okay, I can tell you if you mess up, where you're going to mess up is you're going to say I start at 1, and then you're going to say 1 plus 3, and you're going to get 4 right here. And then you're going to go 5 plus 3, you're going to get 8. 9 plus 3, and that's going to be, I guess, a pattern, but it's going to be the wrong one. And what you're going to end up with is bins that are way too big, and you're going to end up with some empty at the end. Okay, so to have these new class limits, you can do your tally, and if your data set is small enough that you don't have to make tally marks, you can skip the tally marks and go straight to count how many you have. And remember, frequency is just a count. Okay, that's all it is. So for class limits, 5, the number 5 goes here, here, here. And then the number 3 goes up here, 5 back down here, 4 goes here, 2, 1, 6, 8, 7, 4, 1, 1, 10, 9. Okay, so now our frequency is 5, 7, 3, 1. And if we came down here and put them on a number line, we wouldn't put them from 1 to 3. Remember, we would have to bump these together. So we've got to scoot this one this way a little bit, and we got to scoot that one that way a little bit. So we're going to need class boundaries. Okay, we're going to need class boundaries, and this will be 0.5 to 3.5. I changed this one. I bumped it back a half, and I bumped it this way a half. And then this one's going to be 3.5 to 6.5, and this will be 6.5 to 9.5, and this will be 9.5 to 12.5. Okay, so those are my class boundaries. The tally marks are the same. The frequency is the same. It's just that when you go to number line, you've got, 0.5 right here, 3.5 right here, 6.5 right here, 9.5 right there, and 12.5 right there. I'm cheating a little bit because I'm not really spacing out the number line the way it should be. But 1, 2, 3, 4, 5, 6, 7. This one would go up to 5. This one would go up to 7. This one would go up to 3. And this one would go up to 1. And that's what that histogram would look like. And of course, you would need to put your numbers down here. Well, I'll show you in the book that sometimes instead of labeling the ends, like instead of calling this 0.5 and 3.5 and 6.5 and 9.5 and 12.5, sometimes they label the middle. How do you find the middle of something? You add them together and divide by 2. What we would do right here is find what's between 1 and 3. Well, we would label that 2. What was between 4 and 6? That's 5. And what's between 7 and 9? That's 10. And that's 11. No, that's 8. And that's 11. So they might find the midpoint, okay, instead of labeling the ends. Why do they do it different? Because they can. I mean, I think probably because mathematicians are extremely lazy people, and it's less work to label the middle than it is to label the ends. Let me show you. I know you're like, okay, I get it now, but I do want to show you what's important about this rounding rule where I say always round up. So I want to show you what happens. Let's do, we've done 2 bins and we've done 4 bins. Let's do 3 bins right quick, okay? I want a histogram. A histogram with 3 bins. All right, and a histogram with 3 bins, I need always find my class width, and class width is the biggest number minus the smallest number divided by how many bins I want. So 10 minus 1 is 9. 9 divided by 3 is 3. So I'm like, oh, well, I don't have to round it all because it came out to be a whole number. Okay, well, I'm telling you right now, if you think that 3 is your class width, you're wrong. But a lot of people do. You must still round up. You still round up to 4. Because so your class width is 4. Let me show you what happens if you don't use 4 as your class width. Remember, we want 3 bins. Okay, so we're going to have 3 of these. And we start right here at 1. And if our class width is 3, if we use 3 as my class width, then this next bin is going to start at 4. And then we add 3 again. This next bin is going to start at 7. Well, if this one started at 4, then back it up to 3. And if this one starts at 7, back that up to 6. So we did 1, 2, 3, 4, 5, 6, 7, 8, 9. Our 3 bins only go up to 9. Well, what's our biggest number? Our biggest number is 10. And if we use this 3, even though it came out evenly, you don't necessarily have to, it might not, but you could run out of room. All of your numbers won't fit. That's why you should always round up to 4, because if you don't round up to whatever this number is, round up to the next number, you won't have a place for all your numbers. And that's a good way to know that you've messed up. When you start doing your tally marks and you have a number that won't fit anywhere, that's the key. That's your clue that something's wrong. Okay? So now if we round up to 4, and we create our bins, we only have 3 bins, but our class width is 4. We started at 1, so we say 1 plus 4 to get our new starting place. And then we say 5 plus 4 to get our new starting place. So each bin has a starting place. This one stops at 4, this one stops at 8. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now it goes over our biggest number, but at least now our biggest number has a place to be. Okay, so now you could do your class limits. You could do your class boundaries. You can do your tally marks, and then you can do your frequency. Okay, so, and again, like I said, there's no order to this table. I mean, it makes sense to write your class limits down because that's the first thing you calculate. It makes sense to write your boundaries down next because they're very much related to that, but they don't have to go side by side. Class boundaries written first. There's nothing special about the order of my table. You don't have to do the tally marks. I do the tally marks because it keeps everything straight for me, helps me count. So my class limits are 1, and I'm going to do them. If I didn't draw this picture and I wanted to do class without drawing that picture, I can. I still start at 1 and I do 1 plus 4, and that's really in my head. Really don't have to write it down. But 1 plus 4 is 5, 5 plus 4 is 9, and I only had 3 classes, so I only have 3 numbers. So if it starts at 5, this one stops at 4. If this one starts at 9, this one stops at 8, but you can also see that that's plus 4. That's plus 4. It's plus 4 on both sides. Okay, and 8 plus 4 will get me to 12. So there's my class limits. All right, when class boundaries go a halfway, so that'll be 0.5 to 4.5. This will be 4.5 to 8.5. This is 8.5 to 12.5. Now, you have to do this by hand. You're going to see in just a second when I go to the next video and show you on StatCrunch. That StatCrunch doesn't really do this. They do it, but they kind of cheat a little bit. Anyway, you go through here and do your tally marks. 5 goes here, 2, 3. 3 goes here, 5 goes here, 4 goes here, 2, 1, 6, 8, 7, 4, 1, 1, 10, 9. So the frequency here was 772. And then when we build our histogram, okay, you have 3 of them, be 7, 7, 2, something along those lines. And by the way, we'll talk a little bit more later. I've got less than a minute. This down here would be, I don't know what those numbers represent. This, whatever they represent, let's say this is, how many dogs you have. Number of dogs. I asked 16 people how many dogs they have, and that's how many dogs. Somebody has 10 dogs. I don't know what that is. And this over here is going to be frequency. And then this could be up here, the title of all of this. The title of all of this would be, I don't know, survey of my neighborhood. Neighborhood survey. Okay. Title of the histogram, what's being measured on this axis, what's being measured on this. It definitely would need to be scaled with these class boundaries or the midpoint number, either one. Frequency, we need this to be 7 and this to be 2. Anyway, I'll do next video. Uh-oh, I went over.